Unit means it is a reference standard which is used to measure any physical quantity, because of which all over the world we study only certain basic units, as well as from that we derive certain set of units. So whatever we study here, it's the same over in other countries as well, when you just refer to the velocity or acceleration or might be any of the quantities. When this is a case, we have got this solid angle. How exactly we can determine it? Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram School of Excellence, Mysuru, welcoming you all to session 1 of chapter 2, Units and Measurement. And in today's class, we are going to study about the introductory part of units and measurement. So these are like the base things before you get into the class 11. Okay, so it is like, first of all, you studied about the chapter 1, physical world, wherein you had studied about the scientists, their discoveries, law of conservation, unification, reduction, how exactly the science as well as physics originated, which are the scientists, what are their discoveries, all these things were studied in the previous chapter. Into this chapter, you will study how to measure certain things in nature, because the measurement is very much important when you get into the physics. So these two chapters are very, very, very much important, not only in the exam point of view, but also to understand the physics in a better way in your class 11 and class 12 and upcoming classes. Okay, so now here in case of units and measurement, you study that is measurement of any physical quantity is being carried out over here, and that is expressed in case of a unit. Okay, suppose if you just measure an apples, you just say give me 1 kg of apples. Is it that 1 liter of apples you tell? No. But how is that you know? It has to be told. The solid things or the mass, whichever contains the mass, is being called in terms of kg itself. That is all. However, the scientist has given us, you will have to read out the mass in kg, you will have to read out the liquid in liters. This is how we have exactly studied. And how those liters or kg came into existence is our duty to be studied over here. Okay, so now measurement of any physical quantity, it is expressed by a number. Okay, suppose if it is 1 is a number, it is a magnitude. 2 means it is a number, or else it is a magnitude. Understood? So a number is associated with certain unit, and we'll have to study further what are the units that is associated with the mass or liquid or what, solid or liquid or gaseous state, whatever. Okay, so now here it is accompanied by a unit. Okay, so unit means it is a reference standard which is used to measure any physical quantity. So if they ask you define unit or what is unit, it is the standard reference which we are giving to the physical quantity. For example, you can see over here in this image, you can see the thermometer. Okay, it can be given in degree Fahrenheit. Okay, the body temperature is calculated in degree Fahrenheit. When you just calculate the water, that is you tell in degree Celsius, the water boils in 100 degrees Celsius. For that you use degree Celsius thermometer. Okay, Celsius calculated thermometer. Okay, so that is all about how exactly you measure, how exactly the units are present. It is associated always along with a number. So let us see what is meant by a base unit. Units, there are 2 types. One is base unit and one is derived unit. So what is meant by a base unit and what is meant by a derived unit is a concept what we have to learn here. So now coming to the base unit means unit which is adopted for the measurement of the base quantity. Okay, we just adapt ourselves to a very base streams. That is, first of all, you have the base units as an example like meter, which is used to calculate the length, kilogram, which is used to calculate the mass, seconds, which is used to calculate the time, ampere, which is used to calculate the current, Kelvin used to calculate the temperature, mole of the substance, like how much of amount of substance is used, and candela is used to calculate the luminous intensity. Okay, so these are the 7 base quantities what we have to remember. 1 We have first one as meter, second kilogram, third second, fourth ampere, fifth Kelvin, then mole, and then candela. So these are the 7 base units. Other than these 7 base units, we have extra 2 units which you will study later. Okay. So these are the some of the base units. So what is meant by a derived unit? Derived unit means which we derived from the base quantities. Okay, so what are these derived units? We just pick up some base quantities and apply over here so that there is some other unit which is called as a derived unit. For derived units, we can give an example of velocity. That is, for velocity, we just take up meter and take up second. Velocity's unit is meter per second. So, meter is a base quantity, second is a base quantity. So, for velocity, what is the quantity we are having? Meter per second, which is derived from the base quantity or the base unit. Okay, that is why we call this as derived unit. So, base units and derived units together, it is called as system of units. Okay, I hope it's clear for you now. Now let us get into certain system, what we had before and what we are having right now. Okay, so those system of units are called as CGS. CGS system, FPS system, MKS system, which means to say that CGS, centimeter, grams, second is CGS, FPS, foot, pound, seconds, MKS, meter, kilogram, seconds. Okay, this exactly like some of the countries used to use CGS, some of the countries used to use FPS, some of the countries used to use MKS system. As days passed over, what happened in the sense, one country or the one continent people, whichever system of units they were using, and they just proved certain experiments, and when they were discussed with the other countries, when these used to carry on with CGS system, and then when they used to explain with the other countries, they used to find it tough because of the conversion of that CGS to their own units. Suppose if it is CGS system was introduced in MKS system, they used to find it tough in order to convert it from kilograms to mass, from centimeter to meter, grams to kilogram, and from seconds to second. Okay, from here to here, this is two very different when you just convert it, correct? So that used to be very much difficult for the other people to learn, understand, okay? Because of which it was considered by internationally we accepted a measurement that a standard scheme of symbols, units and abbreviations was existed at that time, okay? And it was developed in 1971 by Bureau International Despots. From them, it was introduced that we will have to use SI system or SI units hereafter, okay, which is called as System International. Okay, so this is all about how exactly the SI unit came into existence, because of which all over the world we study only certain basic units, as well as from that we derive certain set of units. So whatever we study here, it's the same over in other countries as well, when you just refer to the velocity or acceleration or might be any of the quantities. So let us just read about some of the basic units, and that is nothing but here you have got list of quantities, here are their units, and the units has got certain symbols which is present over here. So coming to the quantity, we have length. Length is given in terms of meters. Its symbol is small letter m. And next we have mass. Mass unit is kilogram, whose symbol is kg. Next we have time, whose unit is second and whose symbol is small letter s. And next quantity is electricity or electric current, whose unit is ampere, which is given by capital letter A. Next quantity is thermodynamic temperature, which is calculated in case of Kelvin and its symbol is K. Next you have amount of substance, whose unit is said to be mole and whose symbol is said to be MOL. Next you have luminous intensity, whose unit is said to be candela, which is given by CD, as you can see in this diagram, okay? Luminous intensity, it might be time or it might be mass, anything. You have these set of symbols, which is very important, because if suppose the question of the numerical arises in terms of grams, okay, you have to convert it to kg so that you will get the SI unit in the answer. Without the unit, if you just get through the numericals and though you get the answer, you will lose 1 marks because there is no presence of the unit over there. Understood? So unit is must and should. If you get second time in minutes, you have to convert into seconds. Likewise, these are the basic units for which you have to stick on to. Okay. Next, we are coming on to in base unit itself, other than 7 base units, you have 2 more units. Which are those? That is radian and steradian. So here you have got circle. So this is a circle's cut piece. Suppose if this is a circle, from the center you cut the circle into certain angle theta, and here you have got certain displacement, call it as S. So this displacement is called as S and this is called as theta, and this makes a radius R. Okay, so you need to calculate the angle. In order to calculate this angle so here you have, if this is a change in displacement or ds, and you have the change in angle, call it as d theta. So you have angle d theta is equal to arc length divided by radius. So this is the concept, or this is the formula for you to understand about the radian. Radian means it is the unit for a plane angle, which is given as rad. Okay, and steradian, this is the unit for a solid angle. So how exactly you give its formula? So now again you have got a diagram, that is a circular diagram, where you have a 3D diagram, so that here there is an area, call it as dA. Okay, it is just a sphere where you are cutting into a certain angle. When you cut the sphere, you have 3-dimensional figure what exists. So here there is an angle, what it makes, call it as d omega, and this radius is called as r. This is a cone what you consider. Okay, so whenever you consider an ice cream cone, how it will be? It is this. So this is a cut piece, vertical angle, whatever you consider. So here it is d omega, and here this is the shaded part is nothing but it gives the area, and this is nothing but the radius of a sphere what we consider. Understood? So when this is a case, we have got this solid angle. How exactly we can determine it? The angle d omega is equal to the area in this surface, that is superficial circumference area is, from that we have cut an area which gives dA as the area over there. So area dA divided by square of the distance, that is r square. So this is other set of formula for this solid angle which is measured in case of steradian. So you have got radian as well as you have got steradian, 2 angles other than the base units. This is also kind of base units for the sphere. Okay, next the definitions is given over here, that is radian means it is defined as the ratio of the arc length ds to the radius r, and steradian means it is defined as the ratio of intercepted area, that is dA, area of a spherical surface described about an apex, that is this is the apex O, okay, as a center of the square of the radius. Understood? So this is all about your radians and steradians. Okay, next we are going on to measurement of length. So in this concept, how is that we measure the length? The length is measured, there are too many different ways in order to measure the length, as well as too many different instruments in order to measure the length. Few of the instruments can be seen over here, the like screw gauge, vernier calipers, spirometer. All these are the apparatus which is used in order to measure the length of any object which is given to us. Okay, so here the instrument meter scale is the meter scale whatever we use whenever we draw a line in mathematics. All these things we use meter scale. No, that is what it is. Next is screw gauge, vernier caliper, spirometer. All these things you will study in your first PU laboratories, because you can find these in laboratories which is given over here. This is screw gauge, this is vernier calipers, this is spirometer, which is used in order to find out the length. Okay, so next is measurement of the last distance. How exactly you measure the last distance? Is it through the meter scale? No. Is it through the screw gauge? No. Vernier calipers? No. Spirometer? No. Why this screw gauge, vernier calipers, spirometer, all these are used in order to identify or in order to measure the length of the smaller quantities. When it comes to larger distance, we need to measure the length of at the larger distance, like to say it might be planets or anything as such. We used certain method called as a parallax method. So what exactly lies in this parallax method? It's an apparent displacement of an object when observed from two different points. Okay, that is, suppose if you can see here, this is the earth and you have 2 points over here. One point is here, other point, call it as point A and call this as point B. When there is a surface and there are two set of points, point A and point B, we just observe. If I want to see certain planet over here, call it as moon, which I can see over here, this moon. Okay, so now point A, from point A I observe this moon and just draw an imaginary line. So this is the point of sight. Again at point B, this is the point of sight. So I have 2 points of sight from point A and point B to this, called as moon. Understood? So now we have this base. This is called as, this part is known as base, call it as B, and B to this moon, call it as M. It is said to be the distance and it makes an angle theta. Again, as we had studied in case of radian and steradian, it is always the angle theta is equal to the arc which is present over here, B, divided by the distance between them. It is called as D. So theta is equal to B by D, or even you can call it as B is equal to D theta. This is the formula for you to understand the parallax method. Okay, that is how exactly we measure the larger distance of any planets or any other celestial bodies or any other objects. Okay, so the distance between 2 points of the observation is called as basis. Here you can see this is basis, 2 point of observation. If you consider S is a planet, suppose if instead of M I can consider even S also, because S is a planet, the different position from where it is observed is A and B. As you can see here, this is A and this is B, and D is the distance. You can then calculate it in this way. Okay, so that is all about your parallax method. So in today's class we have studied about the introductory part of units and measurement, where we have studied why units are important, what is said to be measurement, and how many types of units are there, that is base units and derived units. So examples for base units and derived units were studied. Okay, and there are 7 base units plus 2 units, and that 2 base units comes under the sphere. Okay, and after which you had studied about the measurement, the instrument which is used for the measuring the length, and finally you had studied the parallax method, that is the method which is used in order to measure the objects which is at larger distance. So that's all for today. Let us all meet in our next session of the same chapter. Until then, have a good day. Thank you.